Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonia Olaoluwa. I'll be taking you through a physics course. Now we'll talk about fluids at rest and in motion. In this topic, we'll be looking at we'll be considering surface tension, some of the applications of the effect of surface tension, adhesion and cohesion, capillary, that is the definition and explanation, viscosity, which is friction in liquids, and application of viscosity. So, what is surface tension? There is this TV series I do watch once in a while on my start time at home, and there's this talk about Jesus walking on the water and several other people who have tried to walk on water. And the scientists said it would be impossible, but they also said it is possible, because nothing really is impossible. What is impossible for certain things or certain people is possible to certain things or certain people. If you watch an ant, you will see an ant actually walk on the surface of the water comfortably. This is due to the presence of a force known as the surface tension. The first surface tension acts like a kind of a skin on top of the liquid, creating a kind of a strength, a kind of like a membrane, looking like a kind of solid across the top of the liquid for a thing to land on. That's one of the reasons why a nylon can actually float on top of water completely. But how does surface tension work? What is surface tension itself? Surface tension is the force acting parallel to the surface of the water. It is given by the expression T equals F over L, that is F divided by L. Where F is the force, L is the distance, that's along the surface of the water. That is the length across which the force is acting. In a few seconds, a question will pop up on your screen. Please, we want to know how much you understand what we have taught so far. Welcome back. Now, before we proceed into looking at the application of the effect of surface tensions, I also like to add one or two things to what we've been taught earlier. How can we reduce surface tension across a particular body, across a liquid? One of the ways to do so is by heating up the liquid. When you apply heat, the kinetic energy in the liquid becomes higher, thereby making the surface of the liquid more loose, increasing the chances of it floating, of anything placed on it sinking. Another way to reduce the surface tension is to add detergents or some chemicals. Now, detergents actually make the liquid, the water, it actually makes it soften. Thereby, it makes the surface of the water lighter. So, the maximum force it can take becomes reduced. Okay, what are the applications of the effect of surface tension? Some of the applications of the effect of surface tension can be found in the making of waterproof materials. Of course, our nylon bags. The understanding of surface tension helps us to understand how to design them such that they would not break and they can withhold what it needs to withhold. Of course, it also helps. Of course, the knowledge of surface tension also is used in the designing and development of chemicals which are used in detergent making. Those are the two applications that are here. I didn't say what I wanted to say when it comes to detergents. It also comes to play in the design and development or choice of chemicals used in making detergents. The kind of chemicals you use actually have to react with the oils So you have to pick something that would react with oil, and for it to react with the oil, it has to break the barrier of the surface tension exerted by the oil, so as to penetrate the oil and to dissolve it out of the cloth. So that's one of the applications. So it does not necessarily have to do with water alone. It might actually have to do with other liquids, other fluids. Adhesion and cohesion. When we talk about adhesion, adhesion has to do with the attraction that exists between the molecules of a particular substance and that of other substances. When a particular substance likes to attach itself to other substances, like the one we find in magnets, that is kind of an adhesive force. While cohesion works with a thing being attracted to molecules of its same kind of substance. That is, it is attracted to its own molecules more than it is attracted to other molecules. It's attracted to its own molecules. We see the forces of cohesion and adhesion come to play a lot in all fluids, especially in liquids. Well, while some fluids have a higher adhesion force than their cohesion force, as in water, some liquids have a higher cohesion force than adhesion force, as seen in mercury. When it comes to surface tension, a higher cohesion force being possessed by a body helps the body to push against any substance from being added to it. But when it has a higher adhesion force, it would easily and more freely let another substance meet and merge up with it, especially if it should have a higher adhesion force towards that thing than the cohesion force it has towards its own molecules. Capillarity is defined as a tendency of a liquid or a substance to rise or fall in a narrow capillary tube. The capillarity of a substance is determined by the interaction of the forces of cohesion and adhesion within the fluid. The same forces which are responsible for to a certain degree of the tendencies of the amount of surface tension that the liquid possesses. In a capillary tube, should we have a capillary tube fixed in this bowl, in this beaker, and there is water or alcohol now, in this particular situation where we set up the capillary tube in beakers, we have water in the first one and mercury in the second one. The one containing water would rise. Why? Because water has a higher adhesion force towards glass than the cohesion force it has towards its own molecules, as against mercury, which possesses a higher cohesion force towards itself than the adhesion force it has towards glass. So let's see, how can we determine the coefficient of surface tension? Earlier we talked about surface tension and we wrote a formula of how to calculate surface tension. Surface tension can be calculated as 2 pi r T. Sorry, let me confirm. I'm correct. 2 pi r T. This talks about the amount of surface tension acting on a particular surface. Then it's been converted to is a measure of the effect of the surface tension acting on a particular face, and it can be compared with mg, which is also a force, that is the weight of the liquid. For the body to actually float or be on top and not sink, when you consider the weight of what is on the liquid and gravitational pull on it, compare it with the surface tension acting. So we want to get what is the coefficient of surface tension. Our expression here is 2 pi RT, and 2 pi RT is representing our surface tension, while 2 mg, that's the effect of the mass on the surface of the water, of course. So let's see what we can get out of it. M, of course, if we want to convert our m to a function of density, we know density is always equal to mass divided by volume. So our m will be equal to density multiplied by volume. That's rho v. So putting our rho v into the equation, we now have 2 pi RT equals to equals to rho v g. We can also simplify our v considering a cylindrical shape. The volume of a cylinder is calculated by pi r squared h. So from the expression, putting this into the expression, we now have 2 pi RT equals pi r squared h rho g, dividing through by 2 pi RT, 2 pi r, we have our t to be equal to r h rho g over 2. You can write that as rho g r h over 2. So our coefficient for surface tension is given by rho g r h over 2. Viscosity. Viscosity talks about a kind of thickness that is experienced, that is how thick a particular fluid is. What it actually does is it brings about the friction that exists within a fluid. It brings about, it is caused by a high cohesion force. The viscosity of a liquid is higher when the liquid has a higher cohesion force within itself. Now, this viscosity it creates a kind of friction that prevents other liquids or other substances from penetrating into the liquid. It makes the liquid thicker. It describes whether the thickness of a liquid. Now, viscosity it can be calculated based on several things, but we have a particular expression, a particular equation that we're supposed to work on, that we're supposed to come to knowledge of as in this particular topic. Let's talk about terminal velocity. When we talk about terminal velocity, a body is being thrown or dropped into water or a fluid from a particular height. Of course, it would come in with a particular force, and that force with which it would come in is known as mg, because it has its own mass and it's coming in. Now, this mg will be opposed by several forces. One of the forces that will oppose it is the upthrust of the fluid. That's U. Another force again that will oppose it, because we said it is a friction, that is viscosity. That's the friction. And the fluid might keep moving. So at the end of the thing, it will have a different acceleration, which is different from the acceleration with which it penetrated. But at the terminal, the body will keep moving. The body will keep moving after it enters the fluid until it approaches or finally gets to the terminal velocity. When it gets to the terminal velocity, it will simply just slowly, with a uniform velocity, sink to the bottom of the fluid. So at terminal velocity, ma will be equal to 0. So with this, we use this usually to calculate the viscosity of the fluid, because we can easily get the upthrust from surface tension, and so viscosity of a fluid can be calculated as mg minus u at the terminal velocity level, at the point of terminal velocity. So what are the applications of viscosity? The knowledge of viscosity has its use in the selection of fluids that are used as lubricants for lubricating parts of machines, because the more viscous a fluid is, the more the chances of it being a very good lubricant. To review everything we've learned under fluids at rest and fluids in motion, we talked about surface tension, and we discussed surface tension as the force that acts parallel to the surface of the fluid. We talked about some of the applications of the effect of surface tension, such as the development of waterproof materials, of course also the design of soaps and detergents. We talked about cohesion and adhesion. We said adhesion is the force that exists between the force of attraction that exists between the molecules of a fluid and that of other materials, while the force of cohesion is one that exists between the molecules of a fluid and its same molecules, that is, molecules of itself. So we talked about capillarity. We said the capillarity is the tendency to rise or fall of a fluid when it is put in a narrow capillary glass. We defined capillarity as the tendency of a fluid to rise or fall when put in a narrow capillary glass. And also we discussed viscosity, and we said viscosity is the friction in fluids. It brings about an opposition to the penetration of things that drop in. We looked at a quick question or a quick description of ball that is dropped from a certain height into the fluid, and we got an expression to calculate the viscosity with the knowledge of the mass, acceleration due to gravity, and the upthrust exerted by the fluid. Also, we said one of the applications of viscosity is it is used in the selection of appropriate materials to be used, appropriate substances and fluids to be used as lubricants. Shortly, some questions will pop up on your screen. Please do attempt them, and if there is any part of this lesson you do not understand, you can review the video.